Allison designs fancy boxes to fill with chocolates. The boxes are in the shape of a right square pyramid as shown, where 8y represents the length of one side of the base of the pyramid, and 5y represents the height of one triangular face of the pyramid. The large box must be designed to have a volume of 1,000 cubic centimeters. The first part of this question asks us to create an equation that can be used to calculate the length of the base and height of the triangular face of the box. And so we need to be able to create an equation. We know it's talking about volume, so the first thing you might want to think about is using our formulas. If we take a look at our formulas, you see that we have a square pyramid, so this is our equation. If you recall from our chapter, we did have some equations where we had this capital B. A general prism does, a pyramid does, and what that capital B stands for is finding the area of that base. So if we take a look at our problem, its volume equals 1/3 the capital B times H. So we have 1/3. The base means the capital B means the area of our base. This is our base. This is a square though, so you can either do 8y squared, where you square both of those, or just 8y times 8y, because we know that our base and our height would be the same, so 8y times 8y. If you want to write it out separate, you can, or you could do 8y squared, but keep in mind that that number would also be squared with the 8. Then times the height, and this is one part that gets a little tricky because we need the actual height as if you're going from here up, straight up, like if you fold your edges across, because this is the triangular face. So this is, for example, if you fold that up, this would be like your side right here, where it is giving you that slanted amount. However, what we need when we figure out our volume is this height right here, because this is the actual height, not necessarily the height of the triangular face, but the actual height of the pyramid. One thing you can think about though is we know this is going to be perpendicular to the ground, so this makes a right triangle. If this is 8y, and you know the center of this would have to be right in the middle, this portion would be 4y. You can use the Pythagorean theorem, but we should hopefully recall that we do have some Pythagorean triples, and one of those Pythagorean triples is 3, 4, 5. Since all of them have a y, you can put a y with it if you'd like, because we really should have that y as well, but here we will have 3y. So again, and if you wanted to use the Pythagorean theorem, it's a squared plus b squared equals c squared. The 5y would be rc, and then we would have a squared plus 4y squared, and you could just simplify it. So a squared would be plus 16y squared equals 25y squared. Subtract 16y squared. A squared equals 9y squared. Square root of both, and that's also another way that you get 3y. If you recognize that this is a Pythagorean triple, you can just recognize that right away and know that your triangle has to be 3, 4, 5. But if you want to plug it into the Pythagorean theorem because you don't remember that, that's how you can apply that to the Pythagorean theorem. So for our volume, for part A, we need to write an equation for volume. So all we have to do is simplify this. 1/3 times 8 times 8 times 3. Will give you 64. If you're not sure, you can always use the calculator to plug that in. If we open up the calculator part, you have 1/3. Then click outside of the fraction to get it to continue, times 8 times 8 times 3. So 64. So the volume equals 64, and then we do have 3 y's in here. Y times y times y will give you y to the third. So this is your answer for part A. So the volume equals 64 y to the third. But we do know what the volume is. So actually, let's take this a step farther, because we can even put in that 1,000 is equal to 64y to the third. So this is our equation, and we can use this to calculate the rest of the information, because now we can solve for y. In order to solve for y, you would divide by 64 equals y to the third. So I'm going to go ahead and replace that v with 1,000. Basically, you just divide both sides by 64 here, and that's why you get the 1,000 over 64, and it cancels over here. Now we have the cubed root. In order to be able to take rid of the fact that this is y to the third, we take the cubed root of it. We haven't done a lot of problems where we've had the cubed root. This is something from algebra, but it's been a while since you've had algebra, so this is what the cubed root looks like. If you're in Desmos, it will just solve this for you, though, so that it helps out a lot with being able to figure out how to simplify. So let's go ahead and take a look at how we do this in Desmos. It's under functions, and if you go into miscellaneous, here is where you have the root. Notice that you can type in whatever root you have. We have a 3, so we'll put a 3 in there. And then 1,000 divided by 64, and it tells us that we have 2.5. So y is equal to 2.5. For part B, it says, what dimensions for the length in centimeters of the base and the height of the triangular face in centimeters satisfy these constraints? Constraints just means the requirements, basically, to be able to make our figure. So what we could do here is the base. For the length, they told us it was 8y. Now that we know that y is 2.5, you just do 8 times 2.5, which should give us 20, but we can always plug it into the calculator just to make sure. 2.5 times 8, we do get 20. Also, the triangular face. Now, notice though that the height of the triangular face is the same wording that we have here, and that's what 5y represents. So not the height of the entire pyramid, not going back to the 3, but we're going back to that 5, because that's what was initially given, and that does represent the height of just one triangular face. And so for 5y, we now know that y is 2.5 though, and so that will give us, should be 12.5. We can always plug it into our calculator just to make sure, which I always recommend. 2.5 times 5, and we do get 12.5. So that would be our final answer. Notice that there are multiple answers, so please make sure that you always try your best. So this would be our answer for A, and both of these answers would be our answers for part B.